Hello guys, in that session we will do something really good, something that will enhance our end interpreter. So it's called String Interning. It's a sort of optimization in strings. So let's see that example. This is the stack state. We have two values with the same value, high and high. So in our case, our interpreter or our memory manager allocate two objects in two different addresses in the heap for the same value, high. And to do some optimization, we need to update our interpreter to allocate one memory for the same value. So we have high, it points to the same allocated address, and that it will save us some extra memory. So let's jump right to the code and do this concept string interning. The first thing we need to do is our VM needs to track every string allocated in the runtime. So to do so, we'll jump to our vm.h and we will add table strings, and we will include table.h. So let's go to vm.c and we will initialize our table, init table vm.strings. So let's go to our object.c. In our object.c, here we allocate string. What we need to do before returning the object string, we need to add that string to the hash table strings. And with some nil value. So let's go to the function take string, and before here we do the optimization. We don't need every time to allocate a new string. We need to check if that string exists in our string hash table. So to do so, we need to declare a variable called object string. Let's call it interned. So I will use a function called find string, and I will pass the string table and chars and the length as well as the hash. So if that intern is different to null, what we need to do is to free array of character char, because remember this function we will use it when we do concatenations. So we need to free the old one, return intern. So let's do the same concept in copy string. We use that in copy string in compile time. Before allocating some string, we need to check if that string exists on the string hash table. And let's pass that here, and if interned different to null, we will simply return interned. Okay, so let's jump to hash table to implement this function table find string. It tells us if some string with that link and that hash table it exists in some table. It returns null if it doesn't exist, and it returns the actual address of that string if it exists in that table. So let's go vim table.h. I will add that function here. Find, okay, table find string table shards length, and also we need the hash of that. So let's come back to implement that. And table.c. Need to do is table find string table and table const shards length hash. So if table none or table count equals 0, we'll return null. And capacity, we need table capacity, excuse me, and also the index hash for the capacity, and we initialize the entry that we want to null, and let's do a loop. Let's initialize that entry to be, let's assign that entry to be at the first position index, and then we will check if entry key equal null. We will check if it is not a entry that's not a Thompson entry. So we'll check if the value is null, we will return null. Else, if we will check entry key hash equal hash and entry key length and we need to compare memory shards length if it is 0, so the 2 is the same, we found it, and what we will do is return that entry key. Remember, because we want only the key. Return entry key. So we will increment our position by 1, and also we need to add module capacity so we avoid to depass the capacity of our table. And finally we return null if all it's failed. Okay, so let's recompile that. Equal what we've done. Okay, chars in object.c 58. Star not chars. Okay, internet. So let's recompile that. Make all. Okay. We'll go to another date here. Okay, that's good. Let's make that. So everything is good. So we need to go to value.c to add the implementation of equal to test if two values are equal. So we need to add that if case val object. What we need to do is to compare. Let's assume that these two values are string. So if is string A and is string B. I did that just to test if they are equal or not. So what we need to do is to return as string equal as string we'll do a break. So let's compile that. Value equal warning. So it's just a warning. So let's test that. Let's do string A equal string B. So they say false. So let's test string A is equal to string A. So they say true. So let's deactivate this optimization. Let's go to object C to see the difference, and I will go to, I will not add that, I will comment that. So just to test if all is okay, the only thing I need is to comment that and that, because remember in compile time we use that function copy string, and for the example I will not use concatenation, so I will do not comment the internal string in that text string, just this to test that. So here is just fine. Okay, let's test that. Let's recompile the project, and I will do string A equal string A. So as you see, it says false, but when we implement the internal string optimization, it says true, because this true, it points to the same memory. Remember, it points to the same memory, and then it says true. And this, it's good optimization, because when we need to compare string, it takes only constant time to compare that, because I will compare only the addresses, not the content. So these two content, it point the same address, and then it says true. So we take the same example, string A and string B, and string A and string A, and we deactivate the internal optimization, and we get false, because it points to different memories. So guys, let's activate that optimization. And let's build the project. Okay, object, let's see. My bad. Okay, string hi equal string hi. It's true. String hi with a capital letter H does not equal string hi with a. It's false. So guys, see you in another session. We've accomplished a good thing. We did a interning optimization. So see you guys in another session to implement variable declaration and assignment. See you guys.